In MCQ 29, this is quite an important question. I will usually phrase this as a green environment-based kind of question. Right, so this is actually quite common as mentioned because we just need to make sure that we can understand the environmental implication. So we have a catalytic converter of the card. So straight up the answer for this question here is definitely going to be redox, but I will just do a little bit of a sidetrack of a revision. So in a catalytic converter, we're going to be having gases like carbon monoxide that comes from the incomplete combustion of fuels, as well as oxides of nitrogen like NO and NO2. Usually, nitrogen should not have a reaction with oxygen in the combustion engine, right? Because nitrogen is rather inert, but because this is a combustion engine, temperature is rather high, this could accidentally increase the frequency of effective collision between the inert nitrogen and oxygen, resulting in oxides of nitrogen from forming. And lastly, unburned hydrocarbons. Fuels that are not burned fully will also be injected into the catalytic converter. So as a hydrocarbon, it has carbons as well as hydrogen that are found with it. So I'm going to have this highlighted as 3 colors: carbon monoxide for yellow, unburned hydrocarbons for blue itself over here, and for the case of my oxides of nitrogen, I'll just have them as pink color. So the catalytic converter attempts to remove these harmful gases and actually have them go through a redox reaction to change them into gases that are less harmful in nature by themselves. So as the term suggests, if this is catalytic, there should be catalyst that's actually involved. And we're looking at things like platinum, looking at rhodium, as well as looking at palladium. All these are transition elements that has catalytic ability. And on top of that, we also make sure that the contact time with the catalytic converter is as high as possible. And to do this, we actually have it into a honeycomb structure. So this honeycomb structure drastically increase the exposed surface area of this metal, so catalysis is much faster and effective. So coming out on the other side, alright, and this is going to be with respect to each of them in colors. Carbon monoxide will be oxidized to form carbon dioxide, less harmful, doesn't bind with your hemoglobin. Unburned hydrocarbons will form carbon dioxide as well as water, less harmful as well. And oxides of nitrogen will be reduced to form N2. So just using oxidation state, carbon itself is -2 plus 2 in carbon monoxide, but it's +4 in carbon dioxide. So this is an oxidation event that we're looking out here. And for oxides of nitrogen, nitrogen is either possessing a +2 or a +4 oxidation state. It becomes 0. So either of them, while they are migrating here, is going to be looking at a reduction process. So this is a redox that we're looking for in the catalytic converter. Answer is D.